Today we're going to talk about factoring by greatest common factor, or GCF. And we're going to begin by factoring each polynomial, and we're going to check some of our answers. So let's start with this first polynomial here. We want to find the GCF of both 2x squared and 4. And the GCF of 2x squared and 4 is 2. Now what we're going to do is divide each of those terms by the GCF of 2. And when we do, the 2's cancel, and we end up with x squared minus 2. And then what we do is we write the GCF in front of our answer. So our factored form right here is 2 times, in parentheses, x squared minus 2. Now if we want to check that, what we're going to do is actually distribute. So we're going to say 2 times x squared minus 2, distribute, and we end up with 2x squared minus 4, which you notice was our original problem. So that did check. And that's basically how you check your answers. You're going to multiply your factors together. So with this next problem, we want to find the greatest common factor of 8x cubed minus 4x squared minus 16x. So we need the greatest common factor of each of those terms. Well, the greatest common factor of 8, 4, and 16 would be 4. Greatest common factor of x cubed, x squared, and x would be x. So we're going to use a GCF of 4x. So we're going to divide every term by 4x. And when we do that, we're going to end up with 2x squared minus x minus 4. And we will put the greatest common factor in front. And so here is our factored form. If you want to check your answer, just distribute. We're not going to check every one of these. I'm just going to show you how to do a couple of them, and then I'll leave you to your own devices. So let's distribute. So 4x times 2x squared gives you 8x cubed. 4x times negative x gives you negative 4x squared. And 4x times negative 4 gives you negative 16x, and that is our original polynomial, so that does check. So let's go to the next one. I didn't mean to have this one have a number in front of it. We'll just cross that out. 3x to the third plus 2x squared minus 10. So we're looking for a GCF here. And, well, the only GCF that we can find for 3, 2, and 10 would be 1. And for x cubed, x squared, and there is no x in the last term, so we can't have an x as part of our GCF. So now if our GCF is just 1, if you go to divide everything by 1, every term by 1, you just get the same answer back. So really, you're not getting ahead of the game at all. You just simply cannot factor this. So we're going to say this cannot be factored. Okay. Next. We have some problems here where we want to factor out a common binomial factor. Now, binomial means 2 terms. So we want to see, are there 2 terms that are common to each of these other terms here? And you notice s plus 6 is part of both of these. So we're going to consider that to be our GCF. And so let's factor that out. So we're going to divide every term by s plus 6. And when we do that, the s plus 6's cancel. And we are left with 4s minus 5. Those are the only things that haven't canceled out. And we're going to put the s plus 6 in front. And so there is our factored form, s plus 6 times 4s minus 5. And I would like to make that 5 look a little bit better so that it doesn't get confused with the s. So let's see if we can do that here. There you go. That's a little bit better. Okay, so now, next, we would like to factor out a common binomial factor here. Notice 2x plus 3 is common to these terms. Now, notice you have something in front of the parentheses for the 2x plus 3 in the first term. We don't in the second term. We should put a 1 there. Remember, I've told you that little trick before. And so our GCF is 2x plus 3. So let's divide everything by 2x plus 3. So the 2x plus 3's cancel, and we're left with 7x plus 1. And let's put our GCF right in front of it. And actually, it really doesn't matter whether you write your answer as 2x plus 3 times 7x plus 1, or you put the 7x plus 1 first, and then the 2x plus 3. It's all the same thing. Doesn't really matter the order in which you multiply. Okay, so next, let's look at this next one. We are looking for a common binomial factor. Now here we have y plus 3. Here we have x plus 4. Those aren't the same at all. So we can't factor out a common binomial factor. So we're just going to say this cannot be factored. Okay. So now let's move on to the next page. We want to factor each polynomial by grouping. And it says check your answer. We'll check one of them, and then I'll let you check the others. What we're going to do, let's group together the first couple of terms and the last couple of terms. Always make sure you've got a plus in between them, which we do here. If not, we'll make accommodations. You'll see that in another problem. Now, what we want to do is find the GCF of each set of parentheses. Well, the GCF of 6h to the 4th and 4h to the 3rd would be 2h to the 3rd. Okay, so we're going to divide each term by 2h to the 3rd. And when we do that, we are going to, and this is only in the first set of parentheses, by the way, we're doing it one set at a time. We end up with 3h minus 2, because the h to the 3rds cancel. And 4 divided by 2, negative 4 divided by 2 is 2. So put your GCF in the front. So we have 2h to the 3rd. Now, in this next set of parentheses, we want to find a GCF. So GCF of 12h minus 8, the GCF would be 4. So let's divide each term by 4. And when we do that, we end up with 3h minus 2. And we want to put the 4 in the front. That is a positive 4, so we'll put a plus 4 there. Okay, notice now we have common binomial factors, so we're going to divide everything by those common binomial factors. Our new GCF, in other words, is 3h minus 2. Okay, so now we're going to cancel out the 3h minus 2. We're left with 2h to the 3rd plus 4, and we will put the 3h minus 2 in front. Okay, so there is our factored form. Now if we want to check this, check it. What we're going to do is just simply multiply using the distributive property. So let's go ahead and do that. So we're going to say 3h times 2h to the 3rd gives us 6h to the 4th. 3h times 4 gives you positive 12h. Negative 2 times 2h squared gives you negative 2 times 2h cubed gives you negative 4h cubed. And negative 2 times 4 gives you negative 8. And so when we put all of this in order, just as it was in the original problem, when we write this in descending order, we have 6h to the fourth minus 4h to the third plus 12h minus 8, which is exactly the problem we started with. So that checks. So that's the only one we're going to check together. All right, let's move on to this next problem. We have 4r to the third plus 24r plus r squared plus 6. Now, let's group the first set of parentheses together and the last set. GCF of the first set is 4r. So we're going to divide everything in the first set by 4r. We end up with r to the second plus 6. Notice in the second set, the only GCF is 1. That's not going to do us any good. But we do need to have a number in front of our parentheses here, so let's put a 1. Basically, what you're saying is the GCF was 1, okay? Oh, and I forgot to put my other GCF in front. I should have put my 4r there. Okay, so I'm going to bring down, we're saying the GCF was 1 times r squared plus 6. Now we have a GCF of r squared plus 6, so let's divide everything by that. Remember, that is our new GCF, r squared plus 6. We're going to cross out, and we are left with 4r plus 1, and put the GCF in front. Okay? Next one. We have something like this, where we want to group together the first and last pair of terms. GCF of the first set of terms would be 3x. So let's divide everything by 3x. We end up with x squared minus, actually it would be 3x squared, I'm sorry. So we end up with x to just x minus 5. I'm sorry, I forgot that little squared term. So we end up with x minus 5, and we'll put 3x squared in front. GCF of the second set of parentheses would be what? It looks like it's 2. So we're going to divide everything by 2. And when we do that, we end up with 5 minus x. Now that's not quite the same as what we have here, okay? Put the 2 in front. However, if we had changed it and divided by negative 2, if we had made that negative and used a negative for our GCF, what would have happened here is, let's change it. Let's see what happens. You would have ended up with negative 5 plus x. And you would have had the negative 2 in front of them. Well, that is the same thing, because really all we have to do is switch these terms around, and we're allowed to do that. So we have 3x squared times x minus 5 minus 2 times x minus 5. Now our GCF is x minus 5. So divide everything by x minus 5. These cancel, and we are left with 3x squared minus 2. And I don't have room to put the x minus 5 in front, so I'll put it in back. It really doesn't matter. Times x minus 5. And there is your solution. So we can do a little bit of manipulation here. I'm going to get you started on the second problem. I'm running out of time here, but notice I said to always make sure that we have everything as a positive. So in between the parentheses when we start off, so we're going to write this as 8y minus 8 plus negative xy plus x. And I'd like you to take that out and see if you can factor that. And we'll talk about it next class. Thank you so very much. for joining me.